Week 10, Code Refactoring and Optimization. lo2, explain common code smells and refactoring techniques used in software development.
Code smells are indicators of potential issues in software design. They do not always indicate bugs but suggest poor coding practices. Code smells reduce readability and maintainability. They increase complexity of software systems. Developers use refactoring to remove code smells. Code smells impact software quality negatively. Common smells include duplicate code and long methods. Poor naming conventions also indicate code smells. Identifying smells improves code structure. Code smells lead to technical debt accumulation. They increase debugging and maintenance effort. Removing code smells enhances software efficiency. Understanding smells is essential for developers. Refactoring helps eliminate these issues. Code smells affect scalability of applications. Code smells are subtle indicators of deeper issues in your software. They don't always mean bugs, but they suggest poor practices that can lead to technical debt. Ignoring them can complicate future maintenance. Identifying code smells is crucial for improving software maintainability and readability. It supports efficient debugging and reduces costs, ensuring your system remains high quality and scalable. Tight deadlines force developers to take shortcuts. Lack of design planning leads to poor structure. Rapid feature addition introduces. Poor communication among team members creates design conflicts. Inexperienced developers may ignore best practices. Legacy system updates without refactoring worsen design. Code duplication occurs due to lack of modular thinking. Over-engineering can create unnecessary complexity. Inadequate documentation is understanding. Improper version control practices introduce redundant logic. Lack of automated testing hides smell detection. Poor naming conventions reduce readability. Ignoring design patterns leads to structural issues. Quick bug fixes introduce hidden smells. Continuous neglect increases long-term maintenance cost. Duplicate code increases maintenance effort and can lead to inconsistent updates. Refactoring consolidates logic, enhancing modularity and reliability, and reducing technical debt. Code smells can be categorized into multiple types. Common smells include long method and large class. Duplicate code is one of the most frequent smells. Feature envy indicates poor responsibility distribution. Data clumps suggest poor data structure design. Primitive obsession reflects misuse of data types. Switch statements may indicate lack of polymorphism.
Lazy class represents unnecessary abstraction.
Dead code increases system clutter. Divergent change suggests poor modularization. Shotgun surgery increases maintenance difficulty. Speculative generality adds unused complexity. Middleman smell reduces efficiency. Message chains increase coupling. God object creates dependency overload. Long methods complicate code understanding and debugging. By refactoring into smaller units, you improve clarity and encourage the single responsibility principle, making your code more manageable. Long methods contain excessive logic within a single function. They reduce readability and comprehension. Testing becomes more difficult with large functions. Debugging time increases significantly. Reusability of code decreases. They often violate single responsibility principle. Developers hesitate to modify long methods. Hidden dependencies are common in long functions. Code duplication often occurs within large methods. Long methods indicate missing abstraction. Extract method refactoring solves this issue. Splitting logic improves modular design. Smaller methods improve readability. Maintenance becomes easier after refactoring. Performance optimization becomes more manageable. Large classes hinder modularity and maintenance. Refactoring improves cohesion and scalability, supporting the separation of concerns and enhancing overall software architecture. Large classes contain too many responsibilities. They violate object-oriented design principles. Changes in one area affect multiple functionalities. Understanding class behavior becomes difficult. Testing complexity increases significantly. Code reuse becomes limited. Refactoring into smaller classes improves design. Large classes often evolve from rapid feature additions. They create strong coupling across modules. Maintainability decreases with class growth. Splitting into cohesive classes improves architecture. Better encapsulation enhances system reliability. Reduces risk of cascading errors. Improves scalability of software systems. Encourages better collaboration among developers. Feature envy violates encapsulation principles, leading to poor modularity. Refactoring reduces coupling, enhances logical organization, and improves readability, making your code more robust. Duplicate code refers to repeated logic in multiple locations. It increases maintenance effort significantly. Bug fixes must be repeated across all duplicates. Violates DRY don't repeat yourself principle. Leads to inconsistent system behavior. Refactoring helps centralize shared logic. Extract method reduces duplication. Template method pattern can address duplication. Inheritance helps reuse functionality. Duplication increases testing workload. Developers may unknowingly introduce duplicates. Version conflicts often arise from duplicated logic. Code readability suffers due to redundancy. Removing duplication improves efficiency. System reliability improves with centralized logic. Techniques like extract method, rename method, and move method enhance different aspects of code. Encapsulation and polymorphism further improve design, ensuring your software is efficient and maintainable. Feature envy occurs when a method heavily uses another class. Indicates poor responsibility allocation. Violates encapsulation principles. Increases coupling between classes. Makes system harder to maintain. Move method refactoring resolves this issue. Improves cohesion within classes. Encourages better object-oriented design. Reduces interclass dependency. Enhances modular system structure. Simplifies testing of individual components. Improves code readability. Reduces future refactoring complexity. Encourages responsibility-driven design. Improves long-term scalability. Refactoring improves readability and reduces technical debt. It supports agile workflows and enhances collaboration, which is critical for developing high-performance, reliable software. By addressing code smells, you'll ensure your software remains scalable and maintainable. This proactive approach enhances system reliability and prepares your code base for future challenges. Data clumps occur when groups of variables appear together repeatedly. Indicates missing abstraction in system design. Increases parameter list length. Reduces readability of function signatures. Introduces potential inconsistency. Refactoring involves creating a new data object. Parameter object pattern helps solve this. Improves code organization. Enhances maintainability. Reduces duplication of data handling logic. Encourages better data encapsulation. Improves object-oriented design quality. Simplifies debugging and testing. Reduces risk of data mismatch errors. Improves scalability of data processing. Now that you understand the importance of refactoring, take action. Review your codebase for smells and apply these techniques to improve your software's quality and longevity. Primitive obsession occurs when basic data types are overused. Indicates lack of proper object modeling. Leads to scattered validation logic. Reduces code clarity. Makes domain modeling weak. Refactoring involves replacing primitives with objects. Enhances encapsulation. Improves validation consistency. Encourages domain-driven design. Reduces duplication of validation roles. Improves maintainability. Enhances readability. Supports extensibility of business logic. Improves overall software design. Promotes reusable domain components. Refactoring is the process of improving code without changing behavior. Enhances readability and maintainability. Helps remove code smells. Improves software performance indirectly. Encourages modular architecture. Supports agile development practices. Reduces technical debt. Makes debugging easier. Improves developer productivity. Enables easier feature addition. Enhances testability of code. Supports continuous integration workflows. Improves team collaboration. Encourages clean coding standards. Essential for sustainable software development. Summary. Now you have successfully achieved Learning Outcome Week 1, Introduction to Advanced Programming Concepts. lo1. Define advanced programming concepts and summarize their role in modern software development. Next, you will learn about Learning Outcome lo2. Explain key programming paradigms and advanced development techniques used in large-scale applications.